so far we've looked at two conic sections, a parabola and a circle. The next one we're going to look at is an ellipse. And we know what an ellipse is. It's shaped somewhat similar to a circle, but kind of a, quote, oblong circle. Well, it has a more specific definition than that. It's the set of all points, P, in a plane, such that the sum of the distances from a point who is on the ellipse and two fixed points, who are both called a focus, another focus, or foci, is a given constant k. And you can just jot this down. Right now it's not going to make a lot of sense. I haven't shown you a picture of what I mean, but we will go through that. And this little formula will hold true that our point, the distance from our point to our first focal point, plus the distance from the point to our second focal point, will end up equaling a constant. And we'll actually even be able to predict how long that constant is. All right, and so we're going to have two concepts called foci, a focal point and another focal point. When it's plural, is called foci. Those are going to be our two fixed points. We're going to have something called a major axis and a minor axis. As you might expect, the major axis is going to be the longer axis. The minor axis is going to be the shorter axis. If I drew a picture of an ellipse, you would be able to tell me where the vertices are. Vertices are going to end up being at the ends of the elongated way, or the major axis. And we're going to have something called covertices, which will be the endpoints of our minor axis, which will be the shorter axis for us. So if we kind of looked generally at what an ellipse looks like, we'll be able to define these terms. But let me make an ellipse, and then the definition will become more clear as to why it is. And I've already made an axis. I'm making it look like maybe it's on an x-axis. And you can see that I have a piece of thread here. It's white. I tried to find a black piece of thread here, but Mrs. Easy must have taken it home. So here's my one fixed point. We would call this a focus, and we would call this point a focus. So we will have two foci. Now, I took a piece of string and I taped it, so hopefully I won't have it move, and kind of pushed it down. And I'm going to take my pencil and I'm going to straighten out that string so it's taut. And I'm going to start here and I'm going to go this way until I get over to this point. And I'm on top of the tape right now there a little bit. And then I'm going to come back and I'm going to finish drawing out this way. Now I'm going to take the string and I'm going to flip it down here. And I'm going to draw some down here. Why don't I start way over there? Whoops. My paper came up. And there is my ellipse. I'm getting a little bit twisted around that pencil lead. So you can see that I kept this string taut. I started way over here and could continue all the way along. Flipped my string down, started way over here, and could continue all the way over. Now, I'm getting caught on that little piece of tape there. Now, let's look back at our definition. We have a set of points in a plane such that the sum of the distances, the sum of the distance from a point P to the two fixed points, is a constant. Okay, so let's look back up here. If I call that point right there P, see how the distance from this focus, this distance, which is the point to the first focal point, plus the point to the second focal point, is going to always equal a constant. It's how long my string is. Now, this axis, this is a vertice. Here would be another vertice. This length is called the major axis. So this whole length is the major axis. And as you might expect, here is a covertice, and here is another covertice. And the length this way, which would be the shorter direction, is going to be the minor axis. Focus, focus, together, foci, and we have, pick any point, say I pick a different point over here, it's always going to hold true that this distance plus this distance is going to equal a constant. It's how long my string is that's connecting those 2 points. And that's what makes my graph turn into an ellipse. Now, as I change these 2 focal points, and if I move them closer and closer together, my shape will look closer to a circle. In fact, if I make both foci be exactly at 1 point, I will get a circle. Okay? So, what does an equation like this look like? Well, an equation like this looks like the following. And we're going to start out and we're going to center, and I'm going to actually redraw these because it's kind of hard just to look at it already done. So we have the equation can look like this: x squared over a squared plus y squared over b squared will equal 1. And in this case, we will always have a larger than b. We can also have x squared over b squared plus y squared over a squared equaling 1. But our standard form that we're going to use will always have the x terms at the beginning. And remember, a is always larger than b. If a and b are equal, we actually have a circle. And we won't write it in this form with them in the denominator. We'll put it in the standard form for a circle. But for an ellipse, if we have the longer measurement underneath the x component, our ellipse is actually going to be elongated in the x direction. If the larger number a is underneath the y squared term, this will actually be elongated in the y direction. So that's an easy way to remember. A is always bigger. If the larger number is underneath x, it's going to stretch in the x direction. If the larger number is underneath the y, it's going to stretch in the y direction. And let's go back to just an example, and then we'll make a generalization and draw a picture up here. Okay, so we want to write an equation in standard form of an ellipse that has a vertex at 0, -4. So 0, -4, 1, 2, 3, 4. And it's a vertex. So I know it's on the major axis. It's an endpoint of the major axis. And I know I have a co-vertice or a co-vertex at 3, 0. And I'm going to have the center at the origin, which means I need to have another co-vertex over here. And I'm going to have another vertice up here, 1, 2, 3, 4, up here. And so my ellipse is going to be elongated this way. It's longer this way. So my form is going to end up being this: x squared over b squared plus y squared over a squared is going to equal 1. And I'm going to have it opening in the y direction as long. Now that means there also are 2 places. If I were going to take that string, the string or the two foci would always be on the major axis between your vertices. There's going to be one over here, one over here. And we'll look at how we figure that out in a minute. So right now, if I want to find the equation, I actually have all the information I need. This distance is called your A. This is also A. This distance is my B. That distance is my B. So I can see that B is 3, which means I would need 9 underneath here. And the A value is 4. I square it. And there is the equation of my ellipse. So if I look up and kind of make a generalization up here about what we have found, is this would mean if I put the A underneath here that it's longer in this direction. So I'm just going to eyeball a point. I'm going to put A to be about this distance to be A. And I'm going to call this distance, if I made these tick marks be 1, 2, 3, 4, 5, 6 this way, I need to go 6 in this direction. 1, 2, 3, 4, 5, 6, just to make it equally spaced. So I would be going over A units this way. So 2A is the length of my major axis. So if you're given a major axis is a specific length, half of that length will be how far you'll go from the center out to your vertices. And this would be a vertice, and this would be a vertice. my little b, I'm not going to go up as high as I did with with the a coordinate because I know this has to be bigger. So I'm just going to make b be 3 units higher, although it's just a generalization. So I'm going to put a b point, and this distance is b up, and 1, 2, 3, b down. And these would be co-vertices. And so your ellipse would look something like this. Now we could actually use string and so on and draw it in. Now the question is, where do these vertices go? There has to be some relationship. How do I know to plot them down here and then tighten that string up to actually draw this? Well, the relationship that holds is that the location of where that vertex is, the focus, there's going to be a focal point right there, and there's going to be another focal point that's going to be over here somewhere. At what ends up happening, and we call this distance C. The distance from the center to the focus is called C. And it ends up being true that A squared equals B squared plus C squared. It ends up that the length from here to here is how long this distance is from here to here. So if I kind of made this triangle a little bit bigger, if this is where the focal point is and this is the center, and we call that little c for the distance from the center to the focus, and this distance is b, that is how long A will be. The length from here to here is actually how long it is on that diagonal. Okay, so that relationship always holds true. Now, I believe the way your book writes it is that c squared equals a squared minus b squared. But if you think in the picture that the distance from the focus is one of the legs of the triangle, the length of half the minor axis is your other side of your triangle, and this diagonal to make up that triangle, that right triangle, is the distance from the center to the vertex. Okay, and if I have an ellipse that is this way, that's going to tell me that's going to be long in the y direction. So let's say I just make this point that this distance is a, and this distance is a. Then the b value, I'll just make this distance be b, and this distance be b. And so this way I would have an elongated ellipse in this pattern. And there are two fixed points that are somewhere on this major axis that are the same distance away from the origin. And so let's say I put one focal point there and one focal point there. This little distance is called C. And likewise, this relationship between the A, B, and C will hold true. A is always the longest measure in an ellipse. This value is longer than B or C, always. Okay, so let's look at another example on the next side. So it says we need to find the foci of an ellipse. And we have this information. We have this equation, and we also want to graph it. Well, we need to put it in the standard form, so I need to divide everything by 9. Divide this by 9, divide this by 9, divide this by 9. Try it again. Let's divide by 36. I want to make this coefficient 1. Don't ask me what I was doing there. I think I was thinking about going home. All right, so anytime we put it in standard form, we want to have a 1. If I just quick flip back over, we need a 1 to be at this end. So always need that to be a 1. So I divide by 36, and then I reduce it down. So I get x squared over 4, plus I have y squared over 36, and I have it equals 1. Now there's my good old standard form. Now this has got to be a squared because it's larger, and I know a is always bigger than b, which tells me that a is equal to 6. And I know that that has to be little b. squared. Therefore, b must equal 2, which I'm going to graph this right away. I'll find the foci in a second. I know it is long in the y direction, and I know a is 6, so I need to count up 6. 1, 2, 3, 4, 5, 6. There is a vertice. Count down 1, 2, 3, 4, 5, 6. There's another vertice. Now I need to go left from center 2 and right from center 2. These are co-vertices. I can see that the major axis is 12 units long if I were asked that question. The minor axis is 4 units long. So kind of eyeballing this in. Now we also have to find the points, the equation, or excuse me, the coordinates of the foci. Now notice they're always on the major axis. So there's going to be one around here, one around here. I know that the c value is smaller than 6. And again, a is always the biggest measure. And a squared equals b squared plus c squared in our elliptical pattern. So we know that 36 has to equal 4 plus c squared. So c squared has to equal, subtracting 4 from both sides, 32. So c is equal to, and I'm not going to worry about plus or minus here because I'm thinking of c as a distance. So we know that it is the square root of 32. And if I ask for an approximate value, we could get a decimal approximation. That's about 5.7. If I said give me the exact value for c, then I would make this into a simple radical. And so I would change that 32 into, I know that that's 16 times 2. So I would know that c would equal 4 times the square root of 2. And now I have to find the coordinates. So I know if you move 4 square root of 32, 4 times the square root of 2 up from center, I would have a focal point, which we said was about 5.7. So there's one focal point there, and its coordinate would be, the x-coordinate is 0, its y-coordinate is 4 square root of 2, and then I would move down to this point, and there would be my other focal point, or my two foci. X-coordinate is still 0. The y-coordinate this time would be 4 times the square root of 2 negative. Now we're ready to use another little concept. So you can see I can give you questions in different ways. And now we have to write the equation of an ellipse. And I know where the foci are, and I know where the covertices are. So I'm going to quick sketch what we know here. And then we have to write the equation of the ellipse. Now I'm not sure quite yet. Once I start to make my sketch, I'll know whether it opens up, down, or whether it's elongated left, right. So we'll see. I have foci at 0, 4, and 0, negative 4. So 0, 1, 2, 3, 4. There's one focal point. 1, 2, 3, 4. There's the other focal point. Now, I know that the major axis has the foci on it. So I know my graph has this be the long axis. So I know it's going to look like this guy. It's going to have the larger number underneath the y. My covertices are at 2, 0 and negative 2, 0. Now I don't know how high to make this go up. And I could actually plop a piece of string down and tape it here, tape it there, and make it taunt like so. And I could actually draw it, but I don't know where that vertex point is, and I don't know where that vertex point is right now. But I do know it's going to be in this form. But I know a little more than that, because I know that this distance is b. So I know this number. And this distance is c. And c is going to be 4 units. And I also remember that a squared equals b squared plus c squared. A is always the longer dimension in an ellipse. And so I can go through and figure out how big a is. A squared is equal to, my b value was 2, so 4. My c value was 4, so 16. And so a squared is equal to 20. Now, if I want to actually figure out how long a is, I would have to square root this. But notice I really just want to write the equation of the ellipse, and all I need is what a squared is. So I'm ready to write my equation. I have x squared over b squared, make sure you square it, and b is 2, so that's 4. Whoops. And, bitch, that lead's going to break again on me. Y squared over, and we have the a squared is 20. And that needs to equal 1. So there's my equation. Now the last one, you may again want to turn the video off and just practice this on your own because it's basically the same question as number 2. And I'm going to write the equation down here. Okay, and remember we want this guy to be 1. So divide everything. I'm going to leave that 1 down there. Now notice that is a squared this time because he's larger. This graph is going to open in the x direction and be wide in the x direction. So we actually know that a is 3. That number is b squared, so b has to be 1. So I actually can graph it right now. The center, go over 3, over 3, go up 1, down 1. He's not a very big ellipse. And now I'm ready to do one last thing. I need to find my foci. A squared equals b squared plus c squared. Remember, a is longest in an ellipse. And I know a squared is 9. I know b squared is 1. And therefore, c squared is equal to 8. Or c is equal to the square root of 8, which would be 4 times 2, 2 times the square root of 2. So my coordinates, if I find that focus, one focus is going to be at x, need to move our x, 2, square root of 2, 0. The other one's going to be over here at negative 2, square root of 2, 0. And we're only working with ellipses being centered at 0, 0 right now. We will change that later, but right now that's where they'll be centered. So now you're ready to practice.